I got a spam call right then. It looked like probably some political crap. Who are you going to vote for? None of your business, okay? So infrared. This is everything gives off infrared. You give off infrared radiation. Okay? We can't see infrared. We can't see. The Predator can. In the movie The Predator, his eyes go boom, and you can see infrared. You can see in the dark. Don't mess with the Predator. But we can't see infrared. I guess supposedly bees can see in infrared, and some night hunting animals like some, what do you call those snake things? Snakes! Snakes. Okay, I know some of you are saying, microwaves are low energy. I cook my food with those. I put my dog in the microwave to warm him up when he's cold and wet. Don't do that. No, these are low energy. However, they will cook food because they have a property that's called resonance, and that means that they make things vibrate. And it happens to be that the microwave has a particular frequency to it that's exactly the same as a water molecule's natural resonant frequency. Resonant means you're moving back and forth. And so you hit that, a water molecule, with a microwave, which is the same frequency. This goes bum, 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 gets highly agitated, and causes water molecules to smack into each other, creating that heat, which is cooking energy. So a microwave is low energy, but it happens to amplify the motion of water particles. If you think about it, when you put stuff in the microwave, out of the freezer, it says add water. Well, why do they want me to do that? Because it's going to make that water that you've added vibrate and move and create heat. So it's low energy, but don't try that at home, people. Don't put yourself in a microwave, or your dog. Low energy, high energy. So there's an equation that goes along with this energy. And the energy equation is E is equal to H times F. Now, this is quantum mechanics stuff, which is the last part of the course, so we're not going to go into all of what light can do because we will be doing that. But for now, we should just know this, that when it comes to energy that a light wave has, or a light photon actually, be more exact about what we're talking about, light energy is directly related, direct relation, to the frequency of the light, the frequency. Oh, we got to talk about those words. Yes, we do. So let's go and talk about those words. What do you mean? What do you mean? Okay, so let's get Roy G. Biv here. The most energetic visible light is violet, and the least energetic is red. All right, let's talk about a little bit about terminology when it comes to a wave. Okay, let's look at a wave. Let's look at a typical wave. There are different kinds of waves. Okay, light is what's known as a transverse wave. That means that the particles move like this as the direction of light is this way. So particle motion, I'll call it PM. Prime Minister, post meridian. No. PM for particle motion. The particle motion in a transverse wave is up and down, like the wheels on the bus, up and down, as opposed to the direction that the wave is moving. So a water wave is actually a combination of what's called a longitudinal wave and a transverse wave, but it's mostly transverse. And what happens is, the wave goes this way, and like if you see a duck on a pond, here comes a wave, what does the duck do? Woo! Does that when the wave goes by. One more time. Woo! That's transverse. So particle motion, direction of the wave. Okay, so this wave that I've drawn, it's a sine wave, really, is what it is. But we will label different parts of it. We need to know different parts. So this is what the top of the wave. Think toothpaste, brush teeth, crest. I think I just advertised for them. They should pay me royalties. So the crest of the wave, this is where the piggies eat. Mommy's little piggy. Oh, mommy, how the piggies eat. Okay, remember, BB gun movie? Yeah, Christmas Story. Mommy's little piggy. Good movie, watch it. If you haven't watched it, you should. Okay, this is the trough. Okay, terminology, simple stuff here, simple. Okay, then between like point to like point, so crest to crest, or trough to trough, we have what's called the wavelength. So let's go trough to trough. And this is going to be my lambda. Lambda, 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 and the Omega moves. Revenge of the Nerds, 1984. Watch that movie too. There's a lot of movies you kids should be watching. So this is the length of the wave. And that's the Greek letter lambda. It kind of looks like a 2 a little bit, but it's a line. I'll make it bigger. A line with a kind of a squiggly thing there. That's the Greek letter lambda. That means wavelength. Okay, there's another important thing when it comes to waves, and that's the height of the wave. The height. It's called the amplitude. The amplitude is not measured, and some of you get this wrong, not measured from crest to trough. Nine. It's measured from the equilibrium point, halfway between the crest and the trough, to the crest or the trough. So that means that would be my amplitude, or that would be my amplitude. So the midpoint to the crest, the midpoint to that's the height of the wave. And that represents energy. Okay? Of course, you know that if you're ever at the beach, at Hampton Beach, and a little wave comes in and hits you, you laugh at it. But then you're out there during a hurricane going by and wiped out. Okay? Lots of energy in tall waves, you know that. So energy is related to that height. Okay. Energy is also related to frequency of a wave. Now, so I'm going to erase this, get rid of this. Okay. All right. We also have what's called the wave equation. Write this down. Do it. Velocity is equal to frequency times wavelength. Okay, velocity is frequency times wavelength. Now we're talking about the velocity of a wave. This is the frequency of the wave and the wavelength of the wave. Now we know what the wavelength of a wave is. We just went over that. Are you paying attention? Are you paying it? Allison, wake up. Wake up. Thank you. James, you awake? Yeah, Mr. Gundram, it's better than being in the boat. That's my joke. James, you've been around me too long. You've been thinking. It's sad. You're starting to think like me. Don't do that. Trust me. Do not go down that road. All right, so we know what the wavelength is, but what's the frequency? The frequency is how many per second. It's the amount of waves per second. In fact, the frequency is equal to what's called 1 over the time period, and the reciprocals of 1 over the time period is equal to 1 over the frequency. So these are two equations that are important. Frequency is 1 divided by the time period. So if it takes a wave a half a second, 0.5 seconds to go by, right? Half a second, then the frequency would be 1 over 0.5, which is equal to, we all know, get the calculator up. Calculator, anyone? Billy, would you? 2? Thank you, Billy. So frequency is 2 to what? 2 hertz. The unit is hertz. H-Z. Hertz. That's 2 hertz. Okay? So what if you had a time period of a wave to be not a half a second, but 1/100th of a second? Okay, so you take 1/100th and divide it into 1, and what do you get? 100. That would be 100 hertz, or 100 waves per second. That would be 100 waves per second. Now, 100 hertz, whew, 2 things about that. 1, that's a lot of pain. 100 hertz. Ow, 100. Sorry, bad joke. And Avis and Enterprise are not going to be happy about that. Get it? Rental car company joke. 100 hertz. Oh, about to roll. Okay. So the frequency is how many waves per second. If you're sitting there and timing it, 1, and 3 waves go by per second, that's 3 hertz. 3 cycles, 3 waves per second. The time period is 1 over the frequency. So if you want to know how long it takes a wave to go by, we can figure that out. If the frequency is 100, then 1 divided by 100 is, well, 0.01, or 1/100th. It takes 1/100th per second to go by. So time, period, and frequency are opposite to one another. Okay, so let's keep going. So frequency, now we know what frequency is. We know what wavelength is, crest to crest. We know frequency, 3 waves per second, 3 hertz. How many per second? Let's look at our equation. Velocity is frequency times wavelength. All right, so we're going to dive into that bad Larry in the next video because it's 10 minutes. Keeping these videos so you can go get a water break, go get some popcorn, go get some root beer, okay? Drink the popcorn and eat the root beer, and we'll be back.